In this video, we're going to look at example 2 in section 17.1. So in this example, we're again going to sketch a curve that's described by parametric equations. So here we're given the equations x equals 1 plus 2t and y equals 2 plus 3t. So notice in the previous examples, we were given maps of the coordinates that included sines and cosines. Here we don't. So right away, we might not be able to tell what kind of curve we have drawn out. So what we need to do is create a table. So we're going to find some x and y values for various t values. So I'm going to look at when t is 0 to start. So when t equals 0, let's see what x and y will be. So x is going to be equal to, or x of 0 is going to be equal to 1 plus 2 times 0, which is just 1. And y will be equal to 2 plus 3 times 0, which is just 2. So we'd have 1, comma 2. So let's look at another one together. So when t is 1, we're going to have x of 1 is going to be 1 plus 2 times 1, which is 3. Y of 1 equals 1 plus 3 times 1, which is 4. So we'll have the point 3, comma 4. So go ahead and pause the video and work out some other values of t for yourself. So maybe 2 when t is 2, maybe when t is -1. After you've done that, feel free to compare your work by continuing the video. All right, so when t is 2, we should be getting 5 and 8. When t is -1, we should be getting -1, -1. So we're not given the parameter or the constraints of what t is. So we can assume that we can use any t in this particular example. So let's go ahead and now plot these values for x and y. So starting at t equals 0, which is always our natural place to start, we look at the point 1, 2. So here we have when t equals 0. Then when t equals 1, we have the point 3, 4. So we're over here. And rather, it looks like I might have made a addition error because y here, hope you caught that, is 2 plus 3 times 1. So we should be getting 5 here instead. So please go ahead and correct that in your notes as well. Okay, the others all should be correct from here. All right, so this point here, rather, let's draw it in the correct place, is 3, 5. So we should go over 3, up 5. So we're going to be here. And that's when t equals 1. So when t equals 2, we're going to be over 5, up 8, which will be this point, t equals 3. Then we see when t equals -1, we're over -1, -1. So that would be when t equals -1. So we can kind of get a sense of what this curve should look like. What do you think? Looks like it's going to be a line to me. Like that. Awesome. So how might we describe this line, and how might we even come to see this line from the equations given? Well, one thing we can always consider when t equals 0, that's kind of our starting point. So this starting point occurs at 1, 2. So we can describe this line by saying we start at the point 1, 2, and we get the line that is parallel to the vector that goes from our point when t equals 0 to our point when t equals 1. So what would this vector be? Well, this vector would go over 2 in the I direction, so 2i, and then 3 in the j direction. So we could say this line starts at 1, comma 2, and is a line parallel to the vector 2i plus 3j. So let's notice that our equations of our coordinates, x equals 1 plus 2t, y equals 2 plus 3t. Do we see this information about our starting point and our line in our parallel vector? We do, actually. So this 1 and 2 describes for us the starting point or starting coordinates. And here our 2t, 3t describe that parallel vector. So here we call these the parallel vector coordinates. And we can really see this play out in our curve. So this 1, 2 is where we are starting when t is 0. And then as t increases by 1 each time, we're going to add 2, 3 to our point. So we're going to add that vector 2i plus 3j each time. So we see that, yes, these two, or this parameterized curve is a line.